Well, today we are doing, we're doing sequences and series.
Okay. What do we got in the way of specific problems?
You let me email it to you right now.
Okay.
I mean, to be honest, all he has, I think, it's not really homework. It's he's all he sent me is problems he's already done. But I don't know if you want to like see them and then maybe you can.
Yeah, let's have a look
make
at
the
it
same
and
type of problem.
we can talk about that. Now,
Okay.
while you're sending that, let me put up a typical sequence, or series rather. What kind of series is that?
An odd series.
That's actually a sequence. A sequence is separated by commas. A series is all the terms are being added together.
Okay.
So, and it goes on forever. So if I wanted the nth term of this series, what would it be? What's the general formula for the nth term of a series?
N is next, right? So it'd be like.
Well, this is a little difficult. That's why I want to go through this.
Okay.
N is the nth term. In other words,
Okay.
I've got an infinite series here.
Yeah.
If I wanted to know the 15th term of that series, well, I could write it out. But what if I wanted to know the 150th term of the series? Well, that's a lot of writing. So I have this formula. So let's say I wanted to know the 150th term. Well, the first term is 1. What's the common difference?
2.
N is 150, so 150 minus 1 is 149. The 150th term of that series is 299.
So wait, how did you figure that out?
Well, I used this formula, substituting 150 for n. It's the first term, which is 1, plus the common difference times n minus 1.
So the common difference is the difference between each number and
each term. If this is an arithmetic sequence, or series, excuse me, there are all kinds of different kinds of series, incidentally. Arithmetic is only one of them. Geometric is another. And there are other series besides arithmetic and geometric. But the ones they tend to teach you at the beginning are arithmetic and geometric. And this is the nth term for an arithmetic series.
What is A?
The first term, a sub 1.
So 1 plus 3 times 149.
Let me put a different series up there and we'll go through it. You'll figure it out. So this series is going to be 4, 7, 10, 13, ...
Yeah.
So now tell me what the 150th term of that series is.
4 plus 3 times 149.
That's the answer.
And then you just work that out in your calculator, or do you even have to?
Yeah, you should always simplify if it's nothing but numbers.
Okay.
Yeah. Your teacher's going to want a number. If he asks you what the 150th term of the series is, he wants a number.
Okay.
Okay?
I sent you it. So.
Yeah, the key thing is that general formula. Got to know that general formula right there. And usually they give you the first term and you can figure out the common difference. So you know a sub 1 and you know d most of the time. Okay, what kind of series is this?
The first one?
Yeah.
A
Is it an arithmetic? Is it an arithmetic or a geometric?
arithmetic.
No?
Oh,
Notice
it's geometric?
+1, +2, +4.
Okay. So it's when it's arithmetic, the difference is always the same, but when
And
it's
when
geometric,
it's geometric, this
it's the
divided
same,
by that it's the same
yeah.
multiplier. In other words, for
Yeah.
arithmetic, let me write the for geometric, let me write the general term for that. For geometric, the nth term is the first term multiplied by the common ratio to the n minus 1 power.
Uh-huh.
So, let's say you're not sure if you got it memorized right. Let's look at this geometric series and figure out what the fourth term is. If the fourth term comes out to be 8, we got it right. So what's a sub 4 going to be equal
to? It's going to be equal to 1 times 2?
Yep. 2 is the common ratio. You get the common ratio by dividing any term by the previous term. That gives you R.
So 1 times 2 to the third, yeah.
Equals 8.
Yep.
So we got it right. In other words, you can always do that on these arithmetic and the geometric nth term formulas. If you ever are wondering whether you remembered it right or not, you can always plug it into a known sequence that you're very familiar with, 1, 2, 4, 8, and if it gives you the fourth term, you probably got it right. Don't have to have it right, but generally I've never found a sequence where it wasn't right, given that. Okay. Now, what's the next value? Clearly 16. And a sub 5, notice. In other words, a sub 5 is equal to a sub 1 times the common ratio to the fourth power. Well, that's 16. Excuse me. Okay. Let me scroll down here. Yeah, a sub n, which confuses a lot of people.
Yeah,
that's just the nth term of the sequence.
Yeah, I get it.
And it doesn't really matter whether you call it a sequence or a series. This is actually a sequence. Okay? It's an arithmetic sequence. The difference between the words sequence and series are a sequence is just a sequence of numbers. They're not necessarily added together. Whereas a series, every number is added together. In other words, if this is a series, it's 1 plus 2 plus 4 plus 8. If it's a sequence, it's just 1, 2, 4, 8, ... Now, let's figure out how they got this. A sub 4. Notice that, excuse me, second. If I use the nth term, I get a sub 1 times the common ratio to n minus 1, right? It's always where you begin. What is the fourth term in the sequence given by that? Sorry, my mistake. Totally different problem. What's the fourth term? Easy. In other words, when they say what's the fourth term, that means n is 4. So that means a sub 4 is 3 times 4 minus 2. Okay. Let's go down a little bit more. kind of sequence is this? Arithmetic?
Which one? The 4, 7, 10, 13?
Yeah, at the top of the page.
Arithmetic. Arithmetic.
Yeah, because every term is separated by a same amount.
Yeah.
It's not multiplied, it's added. Arithmetic is addition going on, geometric is multiplication going on. Now, how did they get that answer? Well, let's go through it. They used the general term. In other words, the general term is a sub n equals the first term plus the common difference times n minus 1. Well, what's the nth term equal to? The first term is 4, common difference is 3, and then it's all they do is simplify that. In other words, that's equal to 4 plus 3n minus 3, which is equal to 3n plus 1. That's how they got the 3n plus 1. Is they took our nth term and simplified it. That's it. You still always start with the nth term general formula. And tell you what, that's an answer to just about all math. If I could teach students one thing and one thing only, it would be start out all your problems with the general format equation. Doesn't matter if you're doing conics, ellipses, circles, vertex format of parabolas, sequences, series, geometric, doesn't matter. Always start out with the general equation. Now, when they talk about recursive
formula.
Yeah. Recursive is a way of relating the nth term to the nth minus 1 term. In other words, I'm going to define the nth term in terms of this term right there. Well, what would the nth term be?
Third or fourth?
Well, it'd be the previous term plus the common difference. So that's the formula for the nth term defined recursively. And like I said, the only thing that recursive means is you're defining the nth term as a function of the nth minus 1 term. So if it's an arithmetic sequence, the nth term is always going to be the previous term plus the common difference. If it's a geometric sequence, the nth term is always going to be the previous term times the common ratio. So let me give you this sequence up here. Okay?
Yeah.
Well, the nth term we know is the first term times the common ratio to the n minus 1. Well, that's not defined recursively. If I want to define it recursively, the nth term has to be the nth minus 1 term, and we can tell it's always multiplied by 2. So if I want to define the nth term recursively, it's the bottom one. If I want to define the nth term by the normal, I can't think of the name. What's the opposite of recursive? Implicit? No?
No idea. What's the point of the recursive formula? Just another
That is an excellent question. I have asked myself that question for 4 years. And guess what? I finally found a calculus student taking Calc 3 that gave me a problem that we had to use the recursive formula. And it took me 3 years to find a situation where, now it makes sense knowing what the recursive formula is. Because you're right. There aren't a lot of situations where the recursive formula is very valuable. it doesn't tell you much because you usually don't know what the next to the last term is. In that previous problem, when I said, what's the 150th term? Well, if we'd have had the formula in a recursive basis, I would have had to know the 149th term. So it wouldn't have done me much good because I didn't know the 149th term. So recursive isn't always that valuable. You've got to, it has to be a problem where they're giving you the n-1 term.
I'm going to probably need to use it in like a problem.
Probably. I'm guessing that they wouldn't.
Not need to in order to like solve it, but like my answer is going to need to be in the recursive formula.
Right. Well, always remember this. Pretty easy. For a geometric sequence, it's always the previous term plus the common difference, right? That's all you're doing, term to term, adding that common difference. For a geometric sequence, it's the previous term times the common ratio.
Yeah.
So those are the two formulas for the recursive formulas for an arithmetic and a geometric sequence. Now, I'm trying to figure out what all this stuff is that he's put below here. Okay. So this answer he has put here applies to this sequence. Notice that the first term of that sequence is 4 when n is 1. And the nth term is always the previous term plus 3.
Yeah.
In other words, the fourth term is always the third term plus 3. Or the third term is always the second term plus 3. So the recursive formula you don't use very often because you have to know what that nth minus 1 term is.
But it's useful, isn't it useful for finding out the next
Not really.
the next one in the series?
Well, you might think so, I suppose.
I guess.
Yeah, okay. So if you tell me that 13 is the fourth term, so I can say a sub 4 is 13, so now I know what a sub 5 is. A sub 5 is a sub 4 plus 3. So it's 13 plus 3. That's it.
But I don't really need that to tell me
you don't
that.
need the recursive formula, do you? In other words, I could have figured out what a sub 5 was from that.
Yeah.
So, like I said, I spent 3 years trying to figure out why we are fed this recursive formula stuff, because I never knew where to use it. And it wasn't until I had a Calc 3 student the other day where he had a problem that involved the recursive formula. So I did have a use for it after all these years.
Yeah, I guess so.
Yeah, in other words, all these answers he gets here are pretty common sense. A sub 5 equals a sub 4 plus 3, so forth and so on. But if you do it this way, you got to go back to a sub 1 and then work your way up to figure out what a sub 1, 2, 3, 4, and 5 are. It's a little easier, in my way of thinking, is just to use the explicit formula for it. I think that's the word, explicit, that I was looking for. You have the explicit formula and you have the recursive formula. And the explicit is based on n. In other words, a sub n is just a function of n. Whereas the recursive is based on the previous term. So you got to know n minus 1 to get anywhere. All right. It's an interesting sequence. like this one. This is not an arithmetic. It's also not a geometric. This is the Fibonacci sequence. And the Fibonacci sequence is every term is the sum of the previous two terms.
Oh, yeah.
So 2 is the sum of 1 plus 1. 3 is the sum of 1 plus 2. 5 is the sum of 2 plus 3. 8 is the sum of 3 plus 5. So this is a very specific sequence. And it happens to have lots of applications in nature. Nature tends to operate on the Fibonacci sequence, believe it or not. It was a tremendous discovery by Fibonacci, assuming that's who came up with it. Probably not the favorite to be the person who came up with it. Most math things are not named after the person that discovered them. Like the Pythagorean theorem was not invented by Pythagoras. And
was that a mathematician, though?
No, I'm just saying that all these names that we have for stuff, like Euler's constant and Riemann's sum and Fibonacci sequence and Pythagorean theorem, they rarely were developed by the person whose name is attached to it. So just because it's called a Fibonacci sequence doesn't necessarily mean Fibonacci is the one who developed it. But notice what it is. In other words, this is useful to define recursively. Any term is the sum of the previous two terms. That's what a sub n minus 2 and a sub n minus 1 means. That's a sub n minus 1 is the previous term. That's two terms previous.
Yeah.
The fifth term would be equal to the third term plus the fourth term. Any sequence that's true is a Fibonacci sequence. I'm not sure it even has to start at 1, 1. In other words, you could even cross those out and you still have a Fibonacci sequence. Because 5 is still equal to 2 plus 3, 8 still equal to 3 plus 5, 13 still equal to 5 plus 8. So it doesn't really matter where it starts, although technically a true Fibonacci sequence probably has to start at 1, 1. All right, let's look at the next one. We don't have much time, but we probably have time for one more problem here.
Okay.
So, what is the sixth term? Well, notice the general formula they give us is the recursive formula, which is unfortunate. That means we have to figure out the first term, second term, third term, fourth term, and fifth term. It's a good thing they didn't ask us what the 60th term was. We'd still be doing it. So the recursive formula is not terribly helpful when you get the first term, because you have to do those 5 or 6 steps. In other words, that gives you the first term, second term, third term, fourth term, fifth term, sixth term. But I got to go through all that math to get it. Had they just given me the a sub nth term, now I kind of see. I could not write this explicitly because it's a Fibonacci sequence. There is no a sub n formula that's not based on the previous term. In other words, I can't write this in a typical way where it would be the first term plus something, so that I can put in one step. The only thing I know about this sequence is that any term is equal to the sum of the two previous terms. So, well, actually that's not true in this case, is it? No, this is not a Fibonacci sequence. Nonetheless, you still have to solve it by solving for a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and then finally a sub 6.
Mm-hmm.
So I got to do it the hard way. And that's what I've always discovered, is that when you get something by the recursive formula, it's rarely easy. You got a lot of steps to do. Whereas if I get something defined by the explicit formula, it's usually just plug in and solve. One step.
Uh-huh.
All right. Dominic, I'm going to call it quits there.
Yep.
And
okay.
Let you go. And I will talk to you Thursday at 4:30 or 4 o'clock my time, 6 o'clock your
time. 6 o'clock.
Now we can pick up from here if you need to, if you're still on this material.
I think I understand this pretty well. Not that. It's pretty straightforward as long as I remember the formula.
Yeah, those general formulas are the key.
We'll probably have some new material to go over on Thursday. I'll see you then.
Sounds good, Dominic. Have a good week. Bye-bye.
Have a good one.